Okay. All right, everybody can see in here?
Yep.
Okay, great. All right, so this is our start of our new unit. We did the factoring review so that this would be easier for you guys. Our new unit is simplifying rational expressions, and the first lesson is simplifying rational functions. Okay, so our learning goals are to simplify a rational function by factoring and learning to determine the domain of a rational function and why it's necessary to include it in the simplified form. So a rational function is the quotient of two polynomials. So one polynomial divided by another, that's what quotient means. Or you can think of it as there has to be a variable in the denominator. So our first example, use factoring to find an equivalent representation for the rational function. Include the domain with your answer. All right, so here's our rational function, f at x equals x squared minus x minus 12 divided by x plus 3. Okay, and what I did was I used my graphing program to make a graph of that function. And we'll talk about why it looks like a straight line, even though it looks pretty complicated over here. And that has to do with us being able to simplify it. So to simplify this quotient, what we would like to do first is factor anything that we can. So we're going to look in the numerator first and see if there's any type of factoring we can do in the numerator alone. So we've got our handy factoring flowchart, and it says to check for common factors first. There isn't any in the numerator. Count the terms. There's 3. And is it a simple trinomial? It is, okay, because there's a 1 in front of the x squared. So now we should be able to factor the numerator. And we know there's going to be an x at the start of each bracket to get the x squared. And then I'm looking for two numbers that multiply to negative 12 and add to negative 1. So we know one's positive, one's negative, and the bigger one's going to be negative. So 1 and negative 12, no. 2 and negative 6, no. 3 and negative 4, yes. So x plus 3 and x minus 4. And then over x plus 3, which can't be factored. The only common factor is 1, and it's not a difference of squares because there's no x squared. So it can't be factored. So what I would like you to notice is that in the top we have x plus 3 times x minus 4, and in the bottom we have x plus 3. So really we have x minus 4 being multiplied by x plus 3 and being divided by x plus 3. So these divide. X plus 3 divided by x plus 3 is 1. And I'm just left with x minus 4. And if you remember from grade 9, grade 10, if I wanted, I can replace f at x with y. If I wanted to draw the picture of y equals x minus 4, it would be a line. It follows that pattern, y equals mx plus b. So b would be negative 4, our y-intercept. So let's look on our graph here. Negative 1, 2, 3, 4 is here. And my slope number, the number in front of x is a 1 over 1 is the rise over the run. So I'd go up 1 over 1. And that works fine, except there's a hole in the graph. Does anyone think they know why there's a hole in the graph? Let's see, the hole in the graph is when x is negative 3. Any ideas why there'd be a hole in the graph there?
It has to do with something with the x plus 3 in the original equation.
Right. So if x was equal to -3 in the original equation, the denominator would be -3 plus 3, which is 0. And is it possible to divide by 0, everybody? No, it is not. Try it on your calculator. Try any number divided by 0 and you get error because it's unknowable to know how many times 0 goes into something. So we say division by 0 is not defined. Okay, so that's when it comes. So what we did here was we simplified, but our other learning goal was learning to determine the domain of a rational function and why it's necessary to include it. Okay, so before I actually cancel here, when I do my steps, I'm going to check and make sure that I never allow the denominator to equal 0. And so I'm putting a restriction, we call it, on the denominator. I'm saying x can never be -3, because if it were -3, the denominator would be 0. But it can be any other real number. So this is kind of when we tack the domain on like this is really the domain here, but when you tack it on, you don't use set brackets and the whole domain equals. You just kind of use comma, and then you tack the domain onto the end. So f of x equals x minus 4 is a simplified version of this, but x can never be -3, but it can be any other real number. And so that shows that when x is -3, there's a hole in the graph because x can never actually equal -3. It can be any other value from -infinity to +infinity. It can just never be -3. Okay, so when you simplify f of x equals x squared minus x minus 12 over x plus 3, your answer is this whole thing, not just f of x is x minus 4. You have to tack on that domain as well. And the reason why is because of the graph. Okay, so even in the questions where I don't give you a graph, you still have to remember to tack the domain on. Okay, so here's another example. Simplify each rational function and state the domain with your answer. So for the first one, we get given a graph again. And the graph might kind of look kind of similar to the reciprocal function from our parent functions, and it does. Okay, it's got an asymptote here. It's probably got another asymptote. Well, we'll determine where it is. I'll show you. But we're going to simplify it. So the first thing we want to do is factor the numerator and denominator as much as possible. So just looking at the numerator and following my factoring flowchart, hopefully you guys can see that that would be a simple trinomial. So I would need two numbers that multiply to 12 and add to +8, and they would be 2 and 6. So that's not so hard. Usually you'll find the factoring in these isn't all that bad, okay, compared to just factoring for the fun of it. And then if we look at the denominator, it's also a simple trinomial. So it's going to factor to give me two binomials as well, but this time I need two numbers that multiply to -30 and add to +1. So one's positive, one's negative. The bigger one is positive. It's not going to be 1 and 30, 2 and 15, 3 and 10. Where does it go in? 5 and 6. So it'll be -5 and +6. So x minus 5, x plus 6. Okay, so we can see that the x plus 6s are going to divide out. But before we do that, we want to restrict the denominator. So the denominator is made up of two numbers multiplying together, x minus 5 and x plus 6. And I'll just do a little refresher from grade 10. Anytime you multiply two numbers together and you get 0, it has to be true that one of the two numbers is 0. Okay, there's the only way to multiply two numbers together and get 0 is if one of them is 0. Okay, and that's really the situation we have in the denominator here. This is a unknown number. This is another unknown number. They're multiplying together, and neither one of them can be 0 because 0 times this number is going to give me 0, or if this one was 0, multiplied by anything is going to give me 0. So the only way x minus 5, that number could be 0, is if x was 5, because 5 minus 5 is 0. And the only way the number x plus 6 could be 0 is if x were negative 6, because negative 6 plus 6 is 0. Other than that, any real number is fine. Any other number you sub into either of these factors is not going to give you 0 in one of those factors. Now, if we look over at the graph, what happens when x is 5? 1, 2, 3, 4, 5. We've got an asymptote there. And what happens when x is negative 6? 1, 2, 3, 4, 5, 6. There's a hole in the graph. Okay, so you can see that there's either going to be an asymptote or a hole at those restricted values, the values that x are not allowed to be. So basically, 5 and negative 6 are not valid inputs. Any other number is. So before you divide out these x plus 6s, which is always really fun to do, crossing stuff out, you have to state the restrictions. Otherwise, if you do it at the very end, you'll miss one or more. So our simplified expression is just going to be f at x is x plus 2 over x minus 5. But then I have to tack the domain on. So I take my restricted values, 5 and negative 6, and then I also add on that it could be any other real number. So any real number other than 5 or negative 6 is the domain there. So again, this part represents the domain, but it's very important that you add it on when we're talking about functions, because that's where there's either going to be an asymptote or a hole in the graph. Okay, so that's the idea. And now we're going to take the graph away and just, oh no, we've got another graph question here. E. Okay, so we're going to look at the numerator first and see if there's any factoring that we can do. So always check for common factors first. And in the numerator, we do have a common factor of 5. So we can common factor 5 out, and we're going to get x minus 4 in our bracket. In the bottom, we have no common factor. Count the terms. There are 3, and it's not a simple trinomial because there's not a 1 in front. It's a complex trinomial. So we're going to have to use decomposition. So off to the side here, I would be thinking to myself, I have to multiply those terms together, and that gives me negative 8x squared. And then I need 2 terms that multiply to negative 8x squared and add to negative 7x. Usually the 1 times table is true if they differ by 1, so it's going to be 1x and negative 8x are going to be the numbers. So it's going to take me a few steps to factor this. You have 2 choices. You could go to a scrap piece of paper and factor it there and then just put the results here, or you can factor as you go. I'm going to factor as I go just so all the steps are on one page. So in the factor as you go method, I'm going to write out my 2x squared here, decompose the negative 7x by putting the negative 8x next because 2 goes into 8, and then the positive 1x, and then the minus 4. So I'm still just factoring here. So I'm just going to recopy the numerator because I'm still just factoring the denominator. It takes 3 steps for decomposition. So then I'm looking at just the first 2 terms there, and they have in the denominator 2x is in common with them. And 2x squared divided by 2x is x. Negative 8x divided by 2x is negative 4. Sign that goes next comes next. 1 is the only thing in common with the second 2 terms. 1x divided by 1 is x. Negative 4 divided by 1 is negative 4. And then this is my last factoring step here. So x minus 4 is my binomial common factor. And the leftovers, which are 2x plus 1, go in the other bracket. So now I've fully factored it. And I can see that I'm going to get to cross those x minus 4s out, so that's exciting. But before I do that, I have to state the restrictions on the factors in the denominator. So for me, x minus 4 by observation, I can tell that if I put 4 in for x, I'd have 4 minus 4, and that would give me 0. So x can't be 4, because I can never have 0 in the denominator, because that's division by 0. But it's harder to see what I would need to put in as x so that the factor 2x plus 1 would equal 0. So when you don't know, you just make up a grade 9 equation. So I'm going to say 2x plus 1 equals 0. I want to know, what does x have to be for the number 2x plus 1 to equal 0. So I've made myself a little grade 9 equation that I can do off to the side here. And back in grade 9, if I wanted to solve for x, I would subtract 1 on both sides. And then I would divide both sides by 2. So what that's telling me is that if I have x as negative 1/2, this factor is going to be 0. So that negative 1/2 is another restricted value. Okay? And if you think about it, or if you do it on your calculator, so 2 times negative 1/2, which I can write as negative 0.5, plus 1 gives you 0. Okay, so I know that my negative 1/2 is a restricted value. And if I look over at my graph, what happens at positive 4? 1, 2, 3, 4, there's a hole. And at negative 1/2, there's an asymptote. Okay, so the graph also leads me to believe those should be the restricted values. This sign looks weird. I'm just going to rewrite it here. All right, so after you've fully factored the numerator and the denominator plus restricted the denominator, now it's time to divide out any like factors. So I can divide out the x minus 4s, and this is what I'm doing. I'm simplifying my rational function. So it started looking like that, which looks pretty complicated, and it's ending up being 5 over 2x plus 1, where x can't be 4 or negative 1/2, but it can be any other real number. And again, the graph looks like that. Okay? You're not going to have to draw the graphs. That's a grade 12 thing, but grade 11, we're going to do the algebra. I just wanted to show you the graphs so you have an idea of why there are those restrictions and how they lead to the domain. So for the rest of the questions, we're just going to simplify and put the domain on the end. Okay. All right, so for C, the first thing you're going to do is look in the numerator and see if you can factor it. May take more than one step, as we've seen. And then same thing for the denominator. So they're using g at x instead of f at x. That's still fine. And we always check for common factors first. So 2 goes into 18, so we have a common factor of at least 2. There's x in both terms, so the smallest exponent is just x. So I'm going to common factor 2x out of the numerator. And it's going to give me x squared minus 9. And in the denominator, 6 goes into 18, so 6 is going to be common, and there's an x in both of them. And then if I common factor that through, 6x squared divided by 6x is x. And then positive 18x divided by 6x is positive 3. So then I have to make sure that my numerator and denominator are fully factored. So again, my factoring flowchart, I common factored in the numerator. There's my common factoring. But then says to count the number of terms inside the brackets, there's 2. So is what's inside the brackets in the numerator a difference of squares? Yes, it is. So I can still keep factoring the numerator, because x squared minus 9 is x minus 3 times x plus 3. But in the denominator, I have two terms in my brackets, but it's not a difference of squares. X plus 3 is not a difference of squares, so it can't factor any further. So now I've fully factored the numerator and the denominator. All right, so before we do any simplifying, we have to restrict the denominator. So I like to think of the denominator as 3 numbers multiplying together. One of them's known, the number 6. It's never going to change, so it doesn't enter into my restrictions at all, multiplying by 6. Then I'm multiplying by the number x, and then I'm multiplying by the number x plus 3. And neither of those 3 numbers can be 0. We don't have to worry about 6 becoming 0 because it's a constant. It's always going to be 6. X can be any value in the world except 0. So x can't be 0. Because if x were 0, I'd have 6 times 0 times 3, which would make the denominator 0. And then the number x plus 3, x could be any number except for -3, because -3 plus 3 would give me 0. So those are my restrictions. Okay, so I'm just going to kind of erase these so you can look at it again. So in the bottom I had 6x, which means 6 times x plus 3. And I can never have 0 in the denominator. And the only ways to get 0 in the denominator would be if x itself was 0, because then I'd have 6 times 0 times 3, which is 0, or if x were -3, because then I'd have 0 here times -3 times 6, which would still be 0. So now that you've got the restrictions on the denominator, you can cancel out any like factors that are in the numerator and the denominator. So x plus 3, the x plus 3's cancel out, but look, so do the x's. And 2 and 6 reduce. They don't cancel, but they reduce to 2 6 is the same as 1 over 3. And then I guess I don't really need that 1. I can just write it as x minus 3 over 3. And then I need my restricted values. And x can be any other real number, so that I've got my domain on the end. So there was more things that we could cancel out there. The x plus 3's were identical. The factors of x were identical. And then 2 6 reduces to 1/3. And 1/3 times x minus 3 is the same as x minus 3 over 3. Okay, the next one. So f at x equals, so the numerator, check for common factors, there isn't any. Count the terms, there's 2. Is it a difference of squares? Yes. So it factors to give me x plus 5 times x minus 5. Look at the denominator, x squared minus 13x plus 40. No common factors, but it's a simple trinomial. So I need 2 numbers that multiply to 40 and add to -13. So to multiply to a positive and add to a negative, they're both going to have to be negative. It's not going to be -1 and 40 or -2 and 20. -3 doesn't go in. -4 and -10. Nope. -5 and -8. Yes, so it's going to be x minus 5 and x minus 8. And then check and make sure the numerator and denominator are both fully factored, and they are. So before I can cancel anything out, I have to restrict the factors in the denominator. So x minus 5 can never be 0, which means x can't be 5. And x minus 8 also can't be 0, so x can't be 8. It's 8 minus 8 is 0. Now that I've done that, I can divide out any like factors that are in the numerator and denominator. So x minus 5 divided by x minus 5 is 1. So I'm left with x plus 5 over x minus 8, where x can't be 5 or 8, but can be any other real number. I have a question that's a kind of an important one that I want somebody to answer. How come in this question, C, I could divide the x's out here, but in this question, I can't divide the x's out here?
Because the x's were part of the a value, or whatever you want to call it.
Okay, so in this case, the x's are part of a factor. So x plus 5 is an unknown number, whereas here, the x's were, if you want to think of them, they're alone. Okay, so 2 times x minus 3 times x plus 3, 6 times x plus 3. The x is alone. It's not part of a factor. Okay, so you can't divide part of something. It's like if you had, I don't know, I'll make it like 155 over 75. You can't just cancel the 5s out. Okay, it doesn't become 15 over 7. That's the thinking if you just canceled those x's out that you'd be using, which you know you can't do, okay? You'd have to factor first. All right, the next one. So instead of f at x or g at x, you're just using y, but we know that they take the place of each other. So 10x minus 15, check for common factors first. And I know that 5 goes into both 10 and 15. So 10x divided by 5 is 2x. Negative 15 divided by 5 is negative 3. And then 4x squared minus 9, there is not a common factor, but there's 2 terms. Is it a difference of squares? Yes. So 2x minus 3 times 2x plus 3. And make sure it's fully factored. It is. Once you're fully factored, you need the restrictions. And again, this one's a bit trickier. I don't know, maybe in my head, what does x have to be for 2x minus 3 to be 0? So that's where you set up the little grade 9 equation, 2x minus 3 equals 0, and you solve for x. So add 3 to both sides. Divide both sides by 2, and you get x is 3 over 2. So x can't be 3 over 2. And same thing, set the same thing up for 2x plus 3 equals 0. Subtract 3 on both sides. Divide by 2. X equals negative 3 over 2. So x can't be 3 over 2 or negative 3 over 2. And I'll show you like a nicer, shorter way to write that in a minute. So you're fully factored and you've got your restrictions on the 2 factors that are in the denominator. So the denominator can't be 0. So now you can divide out. There's a 2x minus 3 divided by itself is 1. So you're left with, you've simplified it to 5 over 2x plus 3, as long as x is not, and here's where you could write plus or minus 3 over 2. Instead of writing them out separately, you could say positive or negative 3 over 2, but it could be any other real number. So you've got your simplification along with your domain. Okay, the next one, f at x equals x minus 7 over 7 minus x. Okay, this is an interesting one because it doesn't look like there's any factoring you can do in the numerator or any factoring you can do in the denominator. I just want to show you, like if I pick a value, say I pick f to be 1, then I would have 1 minus 7 over 7 minus 1, if I'm following this formula, which would give me negative 6 over positive 6, which would give me negative 1. I could try f at 2. I would get 2 minus 7 over 7 minus 2. which is negative 5 over 5, which gives me negative 1. I could pick a negative number, f at negative 3. If I put it in here, would be negative 3 minus 7 over 7 minus negative 3. Negative 10 over 10 gives me negative 1. So I know that this should be negative 1, okay? But this is how you show it. If you remember from our last lesson, the very last question on the last page asked us if this statement was true or false. Does b minus a equal the same as negative a minus b? Okay, and we said it was true. We proved it using a left side, right side check. So this is an identity, which means that you can use it to rewrite anything. So if I want to rewrite 7 minus x, if I follow this, it's like b being 7 and a being x. So b minus a is the same as negative a minus b. So 7 minus x is the same as negative, and then switch them, x minus 7. Okay, so that's an identity. We call it the factor of negative 1 rule. So we're going to use that to rewrite the bottom or the top. We could use it to rewrite the top just as easily. So I can rewrite the bottom as negative x minus 7. Okay, remember we just showed y here. So it follows this rule. B minus a is the same as negative a minus b. 7 minus x is the same as negative bracket x minus 7. And then you want to restrict the denominator. So the denominator can't be 0, so x can't be 7. And now you can divide out the x minus 7. So they divide out, but really what you're getting is 1 over negative 1, which is really just negative 1. But you need the domain. X can never be 7, but it could be any other real number. So remember, we use this identity that we're going to use tons of times in this chapter. And we saw just by subbing it in that it didn't matter what number we chose to put in. When we reduced it, we got negative 1. So it makes sense that x minus 7 divided by 7 minus x should give us negative 1. Okay, G. Okay, so G is a little trick question. X plus 7 and 7 plus x. We don't use that rule because they're exactly the same. Now, look at the difference here. In this question, in the numerator, x was positive and 7 was negative. In the denominator, 7 was positive. I didn't mean to write a 1 in there. I meant to write a positive sign. 7 was positive and x was negative. Okay, so they differed by a negative sign. But in this question, both x and 7 are positive in the numerator and both x and 7 are positive in the denominator. So really, I can just rewrite 7 plus x as x plus 7 without doing anything. I can just change the order. They're both positive. Okay, but now they look exactly the same. They already were, but now we've made them look exactly the same as well. So all we have to do here is say that x can't be negative 7, because then the denominator would be 0, and we can cancel them out, which would give us 1. A number divided by itself is 1, but x can't be negative 7, but it can be any other real number. Okay, the next one, h. h at x. So in the numerator, x minus 5, there isn't a common factor. It's not a difference of squares, so it can't be factored. But in the denominator, there's a common factor of 2. So 10 divided by 2 is 5. 2x divided by 2 is x. So we're fully factored. If we look at it, x minus 5 and 5 minus x are opposites again. In the numerator, x is positive, and in the denominator, x is negative. In the numerator, 5 is negative, in the denominator, 5 is positive. So we want to use that identity. Be careful when you use it in the denominator here, because what we're really doing, I'm going to write 2 steps here, is we're rewriting 5 minus x as negative x minus 5 using the identity that b minus a is equal to negative a minus b. But in the future, this is really 2 times negative 1 times x minus 5. So you can multiply together the 2 and the negative 1 and just get negative 2 times x minus 5. And it would be perfectly fine to go straight from this step to this step. Okay? So you're thinking, I'm going to rewrite this as negative 1 times x minus 5, but I'm going to multiply the negative 1 by the 2 and get negative 2. So you can kind of skip this middle step here. Then we have to, before we cancel these out, we have to restrict the denominator, so x can never be 5, because 5 minus 5 is 0. And now it's okay to divide the x minus 5s out. So that's going to give us a 1 in the numerator, negative 2 in the denominator. X can't be 5, but it can be any other real number. And then this negative sign from grade 9, way back in grade 9, we learned that 1 over negative 2 could also be written as negative 1 over 2 or negative, even with the fraction bar, 1/2. 3 ways to write it. This is the most unusual way to write it. It's not usually considered simplified, so either you want to bump the negative up to the numerator or even with the fraction bar. So I would probably do that, because my answer in the back of the textbook is never going to have the negative with the bottom. It will have it with the top number. So there's my final answer with the domain. I. So right now it looks like the numerator can't be factored. There's no common factor and it's not a difference of squares. Whereas the denominator, no common factor, but it is a difference of squares. So it can be factored. I want my restrictions in the denominator. X can't be 4 or negative 4, so I could write that as plus or minus 4. And this is one of those cases where in the numerator, I have a factor that has a positive 4 and a negative x, and in the denominator, I have a factor that has a positive x and a negative 4. So I'm going to use that identity to change the numerator this time to negative bracket x minus 4. So remember how important this identity is. B minus A is the same as negative A minus B. So now I've got exactly the same factors in the numerator and the denominator, so they can divide out to give me 1. So in the numerator, I'm going to have negative 1. So I have the negative sign still there. In the denominator, x plus 4. And then the domain, x can't be positive or negative 4, but it can be any other real number. Don't forget about like when you cross off the numerator, don't forget there's a 1 still there. Okay, that's a common error I remember from grade 11. All right, so our next one, numerator, no common factor, 3 terms, simple trinomial. So I need 2 numbers that multiply to -20 and add to -1. So the positive and negative, bigger number is going to be negative, not 1 and 20, 2 and 10, 4 and 5. So it's going to be 4 and -5. X plus 4, x minus 5. The denominator, there's a common factor because they both have x. So x is my common factor. X minus 5. And then my restricted values. So the denominator can't be 0, x can't be 0, because 0 times -5 would be 0. And x can't be +5, because 5 times 0 would be 0. So now I can divide out my like factors in the numerator and the denominator. And then tack the domain onto the end, and you're done. And k, h at x equals, so looking in the numerator, is there a common factor? No. 2 terms, is it a difference of squares? Yes. So 3x plus 5 times 3x minus 5. Looking at the denominator, is there a common factor? Yes. 4 is the biggest number that goes evenly into 20 and 12. And then there's an x in both of them. 20x divided by 4x is 5. Positive 12x squared divided by 4x is positive 3x. And then I don't need an identity to turn the bottom one around. Because 5 plus 3x are both positive, so it doesn't matter whether I put the 5 first or the 3x first. 5 plus 3x and 3x plus 5 are exactly the same, but now they look exactly the same, so it's easier for me to cancel them out. But first I have to do restrictions. So the 4 is never going to change. 4 times x times 3x plus 5 is how you think of the denominator. So x can't be 0. From this x here. And maybe I don't know this one, so I make myself a little grade 9 equation. 3x plus 5 equals 0 when? Subtract 5 on both sides. Divide both sides by 3. So 3x plus 5 is 0 when x is -5 over 3. So those are my restrictions. So I can divide out the 3x plus 5s now. So I'm going to be left with 3x minus 5 in the numerator, 4x in the denominator. X can't be 0 or -5 over 3, but it can be any other real number. All right, and the last question. Jenny simplified a rational function, and that should say and got the following solution. So she ended up with f at x equals 2x minus 1 over x plus 4, where x can't equal, those are kind of backwards, but it's okay. -4 or 5, but it could be any other real number. What could the unsimplified rational function have been? What could it have been? So if this is the answer, what could the question have been? Any ideas? Does everyone see that this x can't equal -4 and this x plus 4 go together? So I've taken care of the restriction x plus 4, but x can also not be 5, which means that x minus 5 must have been in the denominator as well. But because it's not showing up in the simplified version, it must mean that it was also in the numerator. And they must have canceled out, right? So that restriction tells me that there must have been an x minus 5 in the numerator and the denominator that canceled out. And then unsimplified, so we will do FOIL. So we make it look like what our questions look like. So here we would get 2x squared minus 10x minus 1x plus 5. And then in the bottom, x squared minus 5x plus 4x minus 20. Combine our middle terms, 2x squared minus 11x plus 5, x squared minus x minus 20. So that's what the question would have been. And then you guys would have gone through all the work to factor it and then finally simplify it with the domain, and you would have got that answer. Okay. All right, I am going to minimize. And stop recording.